By the early 1990s, the streams of Yellowstone's northern range were dying in slow motion. Willows along Soda Butte Creek had been chewed down to woody stubs for 3 generations. Aspen stands that had stood for a century were not producing a single sapling that survived past knee height. Beaver colonies, which the park had once counted in the dozens, were down to a single known lodge. The elk herd that had eaten its way through all of it numbered close to 19,000 animals on ground that should have held half that. The park was not collapsing dramatically, it was collapsing quietly, one missing sapling at a time, and it had been doing so for almost 70 years. On January 12, 1995, a National Park Service truck backed up to a chain link pen in the Lamar Valley and a steel door slid open. A wolf stepped out into the snow. He was the first of his species to set foot on that ground since federal hunters had killed the last pack inside the park in 1926. Within 10 weeks, 13 more were loose. 12 months later, 17 more arrived from British Columbia. 31 founding animals, all of them captured in Alberta and British Columbia, all of them released into a park that had not contained a single wolf in living memory. 10 years later, the willows along Soda Butte were taller than a man. Beaver colonies on the northern range had climbed from 1 to 9. Songbirds that nest in riparian thickets were back in counts no one had recorded in decades. Aspen seedlings were surviving their first winter for the first time in the lifetime of anyone working in the park. That is the famous version of the story. It is also, as the scientists who measured it would later admit, about half wrong. To understand why 14 wolves mattered, you have to understand what Yellowstone had become without them. By the early 1920s, federal predator control had killed the last known wolf pack inside the park. The policy was deliberate. Wolves were vermin. Cougars were vermin. Anything that ate the animals tourists came to photograph was a problem to be solved with rifles and strychnine. By 1926, the solving was finished. For the next 7 decades, the largest predator left in the ecosystem was the grizzly bear. And bears do not hunt the way wolves hunt. Bears scavenge, dig, fish, occasionally take a calf. Wolves run elk down. There is no substitute. Without that pressure, the elk did what unpressured herbivores always do. They multiplied and they stopped moving. By the late 1980s, the Northern Range elk herd was estimated in the high teens of thousands. Somewhere between 16,000 and 19,000 animals on a piece of ground that paleoecologists believe historically supported roughly half that. They stood in the same meadows for weeks. They browsed the same willow stems down to woody stubs. They walked into riparian zones, the green ribbons of vegetation along streams, and they did not leave because nothing made them leave. The willows, the aspens, the cottonwoods along the creeks of the Northern Range were not regenerating. Photographs from the 1930s and the 1980s, taken from the same surveyed points, told the same story in 2 frames. Young trees in the old picture, bare gravel and gnawed shrubs in the new one. A generation of riparian forest was simply missing. This was the Yellowstone the 14 wolves walked into. The first decade after the release moved faster than the biologists expected. Within 3 years, the wolves had organized themselves into packs and were killing elk at rates that surprised even the people who had argued for the reintroduction. Doug Smith, the biologist who has led the Yellowstone Wolf Project since the beginning, has said in interviews that the early kill rates were higher than the modeling had predicted. Wolves took primarily old, weak, and winter-stressed elk the way wolves are supposed to. But they took a lot of them. The elk herd began to fall hard. By the mid-2000s, the Northern Range count had dropped from its late 1980s peak to roughly 6,000 to 8,000. This represented a reduction on the order of half to 2/3, depending on which year you used as the baseline. And then, in places along the streams, something started growing back. This is where the famous story takes hold. Cameras began capturing willow stems above browse height for the first time in living memory. Beavers, which need willow to build with and to eat through the winter, recolonized streams they had abandoned. Beaver colonies on the northern range went from 1 in 1996 to 9 by 2009, a small number in absolute terms, an enormous one in proportional terms. Songbirds that nest in willow thickets returned. Trout populations in some reaches improved as the new shade cooled the water. In 2003, the ecologists William Ripple and Robert Beschta at Oregon State University published the first of what would become a series of papers proposing a name for what they were watching. They called it a trophic cascade. The wolves were not just killing elk, they were changing where elk dared to stand. Elk avoided the narrow stream corridors where ambush was easy. That avoidance lifted the browse pressure off the willows. The willows came back. The willows brought back the beavers. The beavers built dams. The dams stored water, raised the water table, slowed the spring runoff, cooled the streams, and, in Ripple and Beschta's framing, changed the very shape of Yellowstone's rivers. It was the cleanest, most cinematic ecological story of the modern era. It became a TED Talk. It became a viral short film narrated by a British journalist with a soothing voice. It became the line you have heard repeated 1,000 times, "The wolves changed the rivers." That line is not exactly true, and the people who first measured the cascade were among the first to say so. Starting in the early part of the decade that began in 2010, a different group of ecologists began publishing work that complicated the picture. Matthew Kaufman at the University of Wyoming, Kristen Marshall at the University of Wyoming and later at NOAA, and a research team led by Tom Hobbs at Colorado State went into the same valleys with different questions. They were not trying to disprove that wolves mattered. They were trying to figure out how much of what people were seeing was actually wolves. Several things turned up. The elk decline was not driven only by wolves. A severe drought in the early 2000s reduced forage. Grizzly bears, whose population had recovered substantially, were killing elk calves at rates that, when added up across the northern range, removed thousands of animals a year. Cougar populations had quietly increased. Hunters outside the park, drawing on a herd that migrated across the boundary every winter, were taking large numbers. Wolves were one pressure among several. Subtract any one of them and the herd would still have fallen, just more slowly. The willow recovery was patchy. In some valleys, most famously along parts of Soda Butte Creek, willows came back tall and dense as the Cascade story predicts. In others, the willows stayed short and chewed down even after elk numbers collapsed. Hobbs and his colleagues showed that on many stream reaches, the limiting factor was no longer elk at all. It was hydrology. Decades of incised, down-cut stream channels had lowered the water table below the root zone of young willows. Even with no elk in sight, the willows could not reach the water. To bring those willows back, you needed beavers. To get beavers, you needed enough willow for them to start with. And to get that first willow, you needed, in many places, direct intervention, small dam structures, planted cuttings, not just the threat of wolves on the ridge. The behavioral piece, that elk were too afraid of wolves to stand near the streams, turned out to be the weakest link. Studies using GPS collared elk and direct field observation found that elk did not, in fact, dramatically alter where they grazed in response to wolf presence. They altered when they grazed, how vigilantly they grazed, and how they grouped. But the dramatic landscape of fear picture in which elk simply vacated the riparian zones was not what the collars showed. By the late 2010s, the scientific consensus inside the Yellowstone research community had shifted to something less tidy but more honest. Wolves had triggered a cascade, yes, but the cascade ran through a tangled web of drought, bears, cougars, hunters, hydrology, and aspen biology, not a single elegant chain from predator to river. In a 2018 review, Kaufman and his co-authors wrote that the original story had been a useful hypothesis that the data had since complicated. Ripple and Beschta, to their credit, continued to publish updated work that acknowledged the role of other factors while arguing that wolves remained a meaningful driver. The dispute is real and it is still active. So the question becomes, if the famous story is half wrong, what is actually true about what happened in Yellowstone between 1995 and 2025? The honest answer is that something genuinely large took place, and it was bigger than wolves alone. The Northern Range today is not the place it was in 1994. Beaver colonies are an order of magnitude more common than they were at the low point. Cottonwood and aspen regeneration, after stalling for decades, is now happening in measurable patches, uneven, contested, but real. Songbird diversity along the recovering willow corridors is higher than it was during the elk peak. The elk herd has stabilized at a level closer to what the ecosystem appears able to sustain instead of crashing through it. Coyotes, which had become the de facto top predator in the wolves' absence, were reduced by roughly half in the early years after reintroduction, which gave foxes, pronghorn fawns, and ground nesting birds breathing room they had not had in 70 years. Carcasses left by wolves now feed ravens, eagles, magpies, wolverines, and bears through the winter in ways the ecosystem had been missing. None of that is a fairy tale. All of it is in the long-term monitoring data from the National Park Service, the Yellowstone Wolf Project, and a dozen affiliated universities. What the wolves did not do is rewrite Yellowstone by themselves. What they did was act as the last missing piece of a system that had been running with one critical part removed. The system did not snap back to 1872. It moved in a direction. It moved fast in some places and not at all in others. It revealed in the act of moving how much of the damage was structural, such as incised channels, lost beaver wetlands, and drought-altered forage, and could not be undone by predators alone. There's a photograph that the biologists at the Wolf Project sometimes show at the end of their public talks. It is not of a wolf. It is of a single willow stem on Slough Creek, photographed in 1997 and again in 2012. In the first frame, the stem is the height of a man's knee, browsed flat, dying. In the second, it is 12 feet tall and flowering. The willow is not the whole story of Yellowstone. It is one stem on one creek. But 14 wolves walked into a valley in January of 1995, and somewhere upstream of that willow, an elk that would otherwise have eaten it chose, for whatever combination of reasons, to stand somewhere else. That is the smallest possible version of what happened here, and it is the only version no one disputes. The Cascade was messier than the headline. The recovery was slower and less complete than the documentaries suggested, but the valley that received those first animals is not the valley that exists now. And the difference, whatever else you call it, is the difference between an ecosystem missing a piece of itself and an ecosystem that has it back. If this story changed how you think about Yellowstone or about every other miracle recovery you have heard described with the same clean arrow from cause to effect, leave a comment. Tell me which part landed: the 14 wolves, the half-wrong famous story, the willow on Slough Creek. If you are not subscribed yet, this is the channel for it. We tell these stories the way the science actually tells them. See you in the next one.